Hi everyone, so it's Coach Red here, and today we're going to be taking the work that we did in class in the thinking routine and formalizing the rational function. So we know that rational equations may be something of the form like x plus 2 over x minus 1 equals 5. We know it's rational when we have a fraction with a variable in the denominator, and we know that functions like that, or equations like that, have restricted values, whatever is going to make the denominator 0. So what happens to that when I make it a function, something I have to graph? Well, those restricted values still play a role. So for example, if we look at the function y equals 1 over x, we know that our restricted value is that x cannot equal 0. All right, so that means that this part of the function can never be 0. So that also then means that if we can't get that to equal 0, then y equals can never be 0. So y will not be able to be 0. That helps us determine what we talked about in class, our asymptotes. At these values, what happens is we can imagine it as an imaginary line kind of going through those points. So here we've got an x of 0, so we have an imaginary vertical line. We call that the vertical asymptote. And it has an equation. It's a line, so it has an equation of x equals 0. So kind of the opposite of the restricted value. And that y can't be 0, that restriction gives me this horizontal asymptote. And that would be y equals 0. Now, for now, these are actually asymptotes. I want us to think of them as lines that our graph can get really, really close to and not touch. And that's for now, because eventually we're going to show you how there can be holes in them and graphs can actually go through. All right, that means that our graph, if I want to graph it, the best way to do it is to make a table of values. I tend to actually make two. I want to look at my negative values and my positives, but if you make one, that's fine as well. It doesn't really matter. But for this example, I'm going to make two. So I'm going to my inputs and outputs. And I want really nice points to work with here. So if I start on the left side, I might put in the x of -1. And if I put in -1, I get -1. So I plot that point. All right. And then we talked about this in class. A nice point to put in here might be -1/2. Why? Well, if I do 1 divided by -1/2, that actually equals -2. So at -1/2, I'm going to have -2. And for now, 2 points is going to be enough. We know the general shape because we've been looking at it, so it looks something like that. On the other side, I'm going to try 1. So if I plug in 1, I get 1. And if I plug in 2, I get 1/2. Now, if I plugged in 1/2, I would get 2, right? Because 1 all over 1/2 is going to give me 2. So I actually got a couple points here. So let's plot all of them. So I've got 1, 1. I've got 2, 1/2. And then I've got 1/2, 2. So that gave me even more nice points to see that graph going like this. And that's the rational function. Really no harder than that. But let's think about the domain and the range. So the domain is all my x values. So in this case, it's going to be everything but that restricted value, which you've already learned how to write domains in that way. So -∞, 0, union 0, infinity. And my range would be -∞, 0, union infinity. Now, what we did in class was we actually played and worked with these asymptotes. So now let's think about this. If x, one of our restricted values, is that x cannot equal -2, that means that I'm going to have an asymptote at -2. I'm going to get that asymptote drawn in, which you might be saying, wow, it's going to the right. This graph's going to the right 2 units. I'm sorry, to the left 2 units. All right, so if this whole thing cannot be 0, I'm never going to get 0. What if it was 0? If it was 0, that would mean that y would equal -3. But because it can't be 0, that means that y cannot be negative 3. So that's 1, 2, 3. So you might be saying now that means that this graph went down 3 units. And that's exactly what happens. Remember, we've talked about inside moves it left and right, outside moves it up and down. We aren't going to be working with vertical and horizontal stretches or shrinks, but we could be looking at reflections. All right, so then I'm going to make my tables. And I'm just going to plot some points. And again, you want to plot easy points because these get really tricky. We got a fraction here. All right, so I might put in, on the x side, I might put in negative 1. Because if I get negative 1, I get 1 over 1, which is 1, and 1 minus 3 is negative 2. So I have negative 1, negative 2. Oh, that's right here, isn't it? All right, and I might plot 0. I might plot 0. If I plot 0, I get 1/2 minus 3, which would be negative 2.5. So 0, negative 2.5. Oops, that's right here, sorry. And so there's my nice points for me. So I've got a graph that looks like this, and you can see I'm getting really close to that asymptote, but I'm never crossing it. All right, and on the other side, I'm going to put in, oh gosh, if I put in 3, maybe I'll put in 3. I guess I have to put in negative 3. If I put in negative 3, I get negative 1 minus 3, which is negative 4. And if I put in negative 4, I get negative 1/2 minus 3, which is negative 3.5. All right, so negative 3, negative 4, which is right here, and then negative 4, 3.5, so something like that. And so my graph's going to look like that. My domain and range are going to be in line with those restricted values. So negative infinity, comma negative 2, union, negative 2, comma infinity. And then my range is going to be negative infinity, comma negative 3, union, negative 3, comma infinity. All right, so one way we were really thinking about this function right off the bat is, oh, and you know what I want? I want my vertical and horizontal asymptote equations. Let's finish that. So you might notice that vertical asymptote is the line x equals negative 2, and the horizontal asymptote is the line y equals negative 3. So if you write down your restricted values, you can clearly see what's happening here. Now, this is these general functions. We can do functions a different way. Now, the only difference to this function is that I put a reflection in it. A reflection is not going to change your asymptotes because the asymptotes are still going to get shifted. The graph itself might flip. So if it was a reflection, this red graph here would flip under the asymptote, and this blue would flip over the asymptote. And since it's on the outside of the function, it's a reflection over the x-axis. So it's going to be over that horizontal asymptote. All right, so this is telling me this is going right 1, and this is going up 2. So let's see what happens. My restricted values are x cannot equal 1. And so if this whole thing cannot be 0, that means that y cannot equal 2. So my vertical asymptote is x equals 1, and my horizontal asymptote is y equals 2. So you can just see that I shifted my asymptotes 1 unit to the right and 2 units up. Okay, so I'm going to plot some points here. Let me do this pretty quickly. I'm actually just going to do one graph because I'm running out of space. So if I plug in, let's say 2, x of 2, I'm going to get 2 minus 1, which is 1. 1 over 1 is 1. Negative 1 plus 2 is 1. So I've got 2, 1. And I'm going to plug in, how about 3? So 3 minus 1 is 2, so I have a half. Negative a half plus 2 is 1.5. So 3, 1.5. And so I've got this. Oops. I'm going to actually start over here because it turns out a little better, something like that. And then on the other side of the graph, so you can see this one's on the right side is like under the axis. You can see that reflection. On the other side, I'm going to plug in, how about I plug in 0? If I plug in 0, I get -1. I'm going to get a +1 plus 2, which is 3. So 0, 3. And then if I plug in -1, I'm going to get -1/2. And that minus is going to make it +1/2 plus 2, which would be 2.5. So -1, 2.5, and there's my graph. Again, your domain looks at those restricted values, so -∞, 1, union 1 to infinity. My range is my y values, so -∞, 2, union 2 to infinity. All right, so that's actually the lesson. In class, we actually did examples 1 and 2. I think some of you even got to 3, which we'll talk about here later. All right, hopefully that helped. Have a great day.